Hi friends, I'm Deepthi Sharma. Let's talk about a labor leisure problem. So the question is, a worker has preferences given by the utility function n cube y, where n is the hours of leisure per day and y is the spending on purchased goods. The first part says, if the consumer faces a wage rate of W equals to 25, how much of each good do they consume? What is the quantity of labor supplied? Okay, so to solve this, utility function is given by n cube y. N is your hours of leisure per day. Y is your spending. So let H be the hours of work per day. So in a day there are 24 hours, right? So H will be equal to, your hours of work will be equal to 24 minus your hours of leisure. Okay, so 24 minus N per day. So your budget constraint would be given by Y, which is your spending, is equal to your wage rate multiplied by hours of work per day. And so your wage rate is given to be 25 and your hours of work is given to be 24 minus N. So 24 minus N. Now this is equal to, if we simplify, is 600 minus 25N. So we just open up the brackets. 25 into 24 is 600. Minus sign comes as it is, and 25 into n is 25n. Now, in order to calculate the optimal bundle, we have this equation, that mu of leisure divided by your mu of spending, which means marginal utility of leisure divided by marginal utility of spending, should be equal to your wage rate. So there's a negative sign with both of these. We just cancel them out. However, you can also use the Lagrangian method. Both will give you the same answer. I find this is more easy, so I follow this method. So your mu of L, which is your leisure, divided by mu of S, which is your spending, should be equal to your wage rate. Now in our case, my leisure is given by n, so I'll just denote it with n. So mu of n divided by mu of y, which is my spending, is equal to W. So now mu of n is nothing but derivating your utility function n cube y with respect to n. So that gives me 3n square y. And mu of y is given by derivating my utility function with respect to y. So that is equal to n cube. Alright? Okay. Now going for this equation of mun divided by muy equals to W. That's what I write. So I get 3n square y divided by n cube equals to 25. Cancel all the cancellations. You get 3y equals to 25n, or you get 3y divided by 25 equals to n. Now substitute the value of n in the budget constraint. So y is equal to 600 minus 25 into, so your n is given by 3y divided by 25. 25 gets cancelled. So y equals to 600 minus 3y, which is equal to y plus 3y equals to 600. 4y equals to 600. Y equals to 600 by 4, which gives you 150. So 150 rupees is your spending. Now substituting that value of y in your n equation, which is 3y divided by 25, I get my n. That is my leisure. Now hours of leisure. My hours of leisure. 18 hours of leisure. So therefore my hours of work is equal to 24 minus 18, which is given by 6 hours of work. So my quantity of labor supplied is 6 hours. Alright. Now part B says, suppose the wage increases to wage 40, W40. Then what is the quantity of labor supplied? So we do that again in the same equation. So now your wage is 40, so the budget constraint becomes y equals to 24 minus n into 40. So 24 into 40 gives me 960 minus 40n. Again, my MUN divided by MUY should be equal to my W. So 3n square y divided by n cube will be equal to 40. Again, with the cancellations, I get 3y equals to 40n, or I get 3y divided by 40 equals n. Alright. Now substituting the value of n in the budget constraint, I get y equals to 960 minus 40 into 3y divided by 40. So 40 gets cancelled. So I get 960 minus 3y. So 4y equals 960, y equals 960 divided by 4, and I get 240. So in this case, when my wage is 40, I get my spending as 240. However, my hours of leisure is 3y divided by 40 in this case. So 3 into 240 divided by 40. I again get the same hours of leisure, which is 18 hours. I substitute that value into hours of work, which is 24 minus 18. I get 6 hours. So my quantity of labor supplied in this case also is 6 hours of work. Alright. Okay. Hope you got this, and see you next time. Bye-bye.